Module 2, AWS Services. In Module 2, we will introduce core services used as building blocks for common cloud architectures. For each service, we will define what it is, what it does, including examples of what it is used for, and important features that distinguish it. The AWS services we will examine fall into categories of compute, database, networking, storage, administration and security, analytics, and deployment. Part 1. AWS Services. Although the services listed here are not a complete list of all of the AWS products and services, they are some of the most widely used products that you should be aware of. These products and services are used by the largest enterprises and hottest startups to power a wide variety of workloads and applications, including web and mobile apps, data processing and warehousing, storage, and archive. This powerful set of services is available on demand through a web-based management console or programmatically through a robust API. The first product category we'll take a look at is compute, which includes services for cloud-based computing and load balancing. The three products we'll review under compute are Amazon Elastic Compute Cloud, known as EC2, auto-scaling, and Amazon Elastic Load Balancing. EC2 is the primary computing resource. It provides remote server computing with complete control to resize compute capacity as needed. Auto-scaling manages your EC2 capacity automatically, removing unneeded EC2 instances based on parameters that you define. And Elastic Load Balancing automatically distributes incoming application traffic across multiple EC2 instances. We will take a closer look at each of these. EC2 provides you with dedicated virtual servers that have remote access. Unlike the weeks it can take to spec, purchase, and provision server hardware, you can spin up exactly what you need, and in minutes, your servers can be up and running. When you're done using your instances, you stop them and stop paying for them, paying only for what you use. You can do this with a few clicks from the AWS Management Console or using an automated process through an API. APIs are accessible through Sdks in the programming language of your choice. In less than 10 minutes, your instances will be running, and you'll have access with full administrative control, just as with any other server. EC2 provides a range of instance types designed for different use cases. These range from small and economical instances that are a great choice for low-volume applications, all the way up to cluster compute instances designed for high-performance computing workloads and cloud-based supercomputing on demand. Amazon EC2 provides instances optimized for compute, memory, storage, and GPU processing, enabling you to find the right price and performance combination for whatever workloads you want to run. It is also really easy to resize your instances if your application requirements change. To launch your instance, you will select a template or machine image known as an Amazon Machine Image, or AMI, to define your OS, such as Linux or Windows, memory configuration, boot partition size, and so forth. You can choose from a selection of pre-configured AMIs or customize one to meet the optimal settings for your application. AWS offers a broad set of compute instance types. A good example of the breadth of features and of the AWS approach is in the instance types available on EC2. After 8 years, AWS has built out a collection of instance types that move beyond just general-purpose utility computing into application-optimized instances. AWS has spent a lot of time in the past year adding what it considers to be the next generation of instance families to EC2 for both general-purpose workloads and application-specific optimized instances. Today, these instance families have been extended further. General-purpose instance types provide customers with a balanced set of resources and a high level of processing performance on a low-cost platform. Instances in this family are ideal for applications that require balanced CPU and memory performance. Examples of applications that will benefit from the performance of general-purpose instances include encoding, high-traffic content management systems, and memcache. Compute-optimized instances have proportionally more CPU resources than memory or RAM, and are well-suited for compute-intensive applications. Storage-optimized instances provide very high disk I/O performance or proportionally higher storage density per instance, and are ideally suited for applications that benefit from high sequential I/O performance across very large data sets. Storage-optimized instances also provide high levels of CPU, memory, and network performance. GPU instances provide graphics processing units, GPUs, along with high CPU and network performance for applications benefiting from highly parallelized processing, including 3D graphics, HPC, rendering, and media processing applications. Memory-optimized instances offer large memory sizes for high-throughput applications, including relational and NoSQL databases, in-memory analytics solutions, scientific computing, and other memory-intensive applications. The T family are small instances that are ideally suited for low-intensity workloads, such as bastion hosts or jump hosts, test development environments, and learning or experimentation situations. Instances in the T2 family can run low CPU workloads and can spike for periods of time to handle more CPU-intensive tasks. The AWS Marketplace is a great place to get started with hundreds of AWS and partner AMIs pre-configured with the software you need. You can quickly deploy this software to EC2 using one-click launch or with the EC2 Management Console. AWS provides a number of pricing models for EC2 to help customers save money. Customers can combine multiple purchase types to optimize pricing based on their current and forecast capacity needs. On-demand instances let you pay for compute capacity by the hour with no long-term commitments. This frees you from the costs and complexities of planning, purchasing, and maintaining hardware, and transforms what are commonly large fixed costs into much smaller variable costs. On-demand pricing works well for spiky workloads. Reserved instances give you the option to make one upfront payment for each instance you want to reserve at a significant discount. Using the reserved option, you can get a rate that is 50 to 75% lower than the on-demand rate. Reserved pricing works well for steady-state workloads with committed utilization. Spot instances enable you to bid for unused Amazon EC2 capacity. Instances are charged the spot price, which is set by Amazon and fluctuates depending on the supply of and demand for spot instance capacity. Spot pricing offers the best hourly rate and works best for workloads that are not time-dependent and which can afford to be interrupted. Dedicated instances run on hardware dedicated to a single customer. Dedicated instances ensure that your Amazon EC2 compute instances are isolated at the hardware level. Some customers use dedicated instances to allow them to run third-party software, where the licensing model demands that the hardware is dedicated to one tenant. They then fill the rest of their workloads with either on-demand or spot instances. We have covered the AWS pricing models help you optimize your cost savings based on your unique requirements. You can take full advantage of cloud computing benefits and on-demand elastic provisioning with the control and security your applications require, while paying only for what you use. We have covered Amazon Elastic Compute Cloud, or EC2, and its resizable compute instances you launch using an AMI, or Amazon Machine Image. Next, we'll take a look at how auto-scaling can help you manage your EC2 capacity by automatically removing EC2 instances when you no longer need them. Auto-scaling supports application availability by allowing you to automatically scale your EC2 capacity up or down based on parameters that you define. You can set demand thresholds to have auto-scaling increase the number of EC2 instances during demand spikes, or shed underutilized capacity when demand is low. This helps you maintain performance while reducing costs by removing instances during lulls. For example, you can set a condition to add new Amazon EC2 instances in increments of 3 instances to the auto-scaling group when the average CPU utilization of your Amazon EC2 fleet goes above 70%. And similarly, you can set a condition to remove Amazon EC2 instances in the same increments when CPU utilization falls below 10%. Often, you may want more time to allow your fleet to stabilize before auto-scaling adds or removes more instances. You can configure a cooldown period for your auto-scaling group, which tells auto-scaling to wait for a defined amount of time after taking an action before it evaluates the conditions again. You can also use auto-scaling to maintain your EC2 fleet at a set size. If you're sure you want to run a fixed number of Amazon EC2 instances, auto-scaling helps ensure you'll always have that number of healthy Amazon EC2 instances available and running. You can create an auto-scaling group and set a condition that your auto-scaling group will always contain this fixed number of instances. Auto-scaling evaluates the health of each Amazon EC2 instance in your auto-scaling group and automatically replaces unhealthy Amazon EC2 instances to keep the size of your auto-scaling group fixed. This ensures that your application is at the compute capacity you expect. You can also use auto-scaling with elastic load balancing, or ELB. Let's say you always want at least 2 healthy Amazon EC2 instances behind an ELB load balancer. You can use auto-scaling to set this condition. And when auto-scaling detects that this condition has been met, it automatically adds the requisite amount of Amazon EC2 instances to your auto-scaling group. Or, if you want to make sure that you add Amazon EC2 instances when latency of any one of your Amazon EC2 instances exceeds 4 seconds over any 15-minute period, you can set that condition. And auto-scaling will take the appropriate action on your Amazon EC2 instances, even when running behind a load balancer. Auto-scaling works equally well for scaling Amazon EC2 instances, whether you're using elastic load balancing or not. Auto-scaling is well suited both for applications that have stable demand patterns and for those that experience hourly, daily, or weekly variability in usage. It enables you to run your Amazon EC2 fleet at optimal utilization, and the service is included free of charge in all EC2 instances. Elastic load balancing works with EC2 to automatically distribute incoming application traffic across multiple Amazon EC2 instances. It enables customers to achieve a high fault tolerance in their applications by detecting the health of EC2 instances and removing failing instances. When unhealthy instances are detected within a pool, elastic load balancing automatically reroutes traffic to healthy instances until the unhealthy instances are restored. You can also enable elastic load balancing across multiple availability zones for more consistent performance. Elastic load balancing offers some important features to support your application, including HTTP, SSL, and TCP protocols, SSL offloading, sticky session, Layer 4 or Layer 7 load balancing, operational monitoring, and logging. It also integrates seamlessly with auto-scaling to add and remove instances based on scaling activities. We have learned about EC2 instances, elastic load balancing, and auto-scaling, which you will use in the most widely used AWS solutions. Additional compute services are available to help you build customized solutions. Learn more at aws.amazon.com. The next product category is database. AWS offers a number of database services. The service we will explore in this section is the Amazon Relational Database Service, or Amazon RDS, which makes it easy to operate and scale a relational database with your cloud-based computing solution. It provides cost-efficient and resizable capacity while managing time-consuming database administration tasks. As with all AWS services, there are no upfront investments required, as you pay only for the resources you use. With Amazon RDS, you get native access to a relational database. This facilitates compatibility with your preferred tools and applications. You can use Amazon RDS with popular database engines, including SQL, MySQL, Oracle, and Postgres. You can also use RDS to apply point updates automatically or to monitor the compute and storage resource utilization of your database instance for no additional charge. Amazon RDS is fully managed and offers fast, predictable performance. It handles time-consuming database management tasks such as backups, patch management, and replication, allowing you to focus on higher-value application development or database refinements. Additionally, the provisioned IOPS is a high-performance storage option designed to deliver fast, predictable, and consistent performance for I/O-intensive transactional database workloads. You can provision from 1,000 IOPS to 30,000 IOPS per database instance. Amazon RDS is tightly integrated with other AWS services. For example, an application running in Amazon EC2 will experience low latency database access to an Amazon RDS database instance in the same region. Amazon RDS offers some key benefits. First, it is elastic. This means that you can provision additional storage on the fly with zero downtime. As mentioned earlier, RDS offers you flexibility through a range of choices for your database engine, including SQL, MySQL, Oracle, or Postgres. In addition, Amazon RDS gives you control over which database engine version powers your database. RDS helps keep your applications secure and available with database security groups, SSL connections, automated backups, database snapshots, and multi-AZ deployments. You can configure firewall settings that control network access to your database. You can also isolate your database instances by running your database instances in Amazon Virtual Private Cloud, where you can specify the IP range you wish to use, and connect to your existing IT infrastructure through industry-standard encrypted IPsec VPN. Often databases are steady state, so using RDS reserved instances can help make the cost of running on AWS even lower. We have learned about RDS, the Managed Relational Database Service for MySQL, Postgres, Oracle, SQL Server, and Amazon Aurora. AWS also offers Amazon DynamoDB for NoSQL data stores, and Amazon ElastiCache, an in-memory caching service. Learn more about these services at aws.amazon.com. Amazon Web Services provides a range of networking services. It enables you to define a logically isolated network, establish a private network connection to the AWS cloud, use a highly available and scalable DNS service, and deliver content to your end users with low latency and high data transfer speed. In the networking product category, we will look at Amazon Virtual Private Cloud, or VPC, and Route 53. Amazon VPC is a virtual cloud-based network that allows you to provision a private, isolated section of the AWS cloud. Amazon Route 53 is a scalable domain name system, or DNS, where you create and manage your public DNS records and the IP addresses listed for your domain names. We will take a closer look at each of these. You can build a private virtual network in the AWS cloud using Amazon VPC. No VPNs, hardware, or physical data centers required. You have complete control over your virtual networking environment. You select your own IP address range, create public and private subnets, build network topologies, and configure route tables and network gateways. You control inbound and outbound access to and from individual subnets using network access control lists. Alternatively, you can use the AWS Management Console and the VPC wizard to automatically create subnets, IP ranges, route tables, and security groups. Using VPC also allows enterprises to extend their data center to the cloud by connecting their existing infrastructure to Amazon EC2. You can leverage security options, which have been greatly enhanced, to provide more granular access both to and from the Amazon EC2 instances in your virtual network. You can also attach an Amazon Elastic IP address to any instance in your VPC, so it can be reached directly from the internet. And you can bridge your Amazon VPC and your on-site IT infrastructure with an encrypted VPN connection. You can connect your VPC to the internet using an internet gateway, your corporate data center using a hardware VPN connection using the virtual private gateway, both the internet and your corporate data center, using both an internet gateway and a virtual private gateway. Other VPCs, using VPC peering connections. Amazon VPC provides these key benefits. It provides the same elastic scalability as the rest of the AWS platform. You can instantly resize your resources up or down with up to 200 subnets per VPC. Amazon VPC is highly configurable to meet your specific needs. With VPC, you have complete control to configure subnets, IP ranges, route tables, and security groups, or to use the VPC wizard to have those settings automatically created for you. You can also connect your VPC with other VPCs and access resources in other VPCs using private IP addresses. Amazon VPC provides advanced security features such as security groups and network access control lists to enable inbound and outbound filtering at the instance level and subnet level. In addition, you can store data in Amazon S3, which we'll discuss shortly, and restrict access so that it's only accessible from instances in your VPC. There are no additional charges for creating and using the VPC itself, aside from the usual Amazon EC2 charges. If you connect your VPC to your corporate data center using the optional hardware VPN connection, pricing is per VPN connection hour. Amazon Route 53 is a highly available and scalable DNS service that gives you convenient access for managing your DNS records and IP addresses. It answers DNS queries with low latency by using a global network of DNS services to resolve user requests to AWS resources as well as to infrastructure outside of AWS. And with the pay-as-you-go model, you pay only for managing domains through the service and the number of queries that the service answers. Route 53 allows you to choose a routing policy specific to your priorities and configuration. Two of those routing policies include latency-based routing and weighted round-robin. If you have resources in multiple AWS regions, Route 53 can use latency-based routing to respond to a DNS query based on which data center gives your user the lowest latency. Or if you have resources in multiple data centers that perform the same function, such as a website, you may want to specify what proportion of the traffic to send to each server. For example, 40% to one server and 60% to the other, using a weighted routing policy. Use the failover routing policy to automatically route your website visitors to an alternate location if the primary resource becomes unavailable. This policy helps prevent site outages. You can learn more about these and other routing policies on the AWS documentation site. A number of important features for Route 53 help support the stability and accessibility of your applications. Amazon Route 53 is integrated with Elastic Load Balancing, or ELB. When you use CloudFront to deliver your website content, visitors to your website can now access your site at the zone apex or root domain. For example, your site can be accessed as mywebsite.com instead of www.mywebsite.com. Visitors to your website hosted on Amazon S3 can access your site at the zone apex or root domain. Amazon Route 53 works with the AWS Management Console. This web-based, point-and-click graphical user interface lets you manage Amazon Route 53 without writing any code at all. We have learned about VPC and Route 53 networking services. AWS also offers a dedicated network connection to AWS called Direct Connect. Learn more at aws.amazon.com. AWS provides a range of low-cost data storage services with high durability and availability. The three products we'll review under storage include Amazon Elastic Block Store, known as EBS, Amazon Simple Storage Service, or S3, and Amazon Glacier. Amazon EBS is the persistent block store for use with Amazon EC2. You can create partitions, format it, boot your OS off it, or do anything you would usually do using a hard drive. Amazon S3 is a durable, scalable object store similar to a collection of static files. It features a web interface that can be used to store and retrieve any amount of data from anywhere on the web. In comparison, Amazon Glacier is optimized for archiving and backup. It is best for data where longer retrieval times are suitable and where high durability is needed. We will take a closer look at each of these. Amazon EBS, the persistent block store for use with Amazon EC2, is similar to a hard drive. You can store from 1 gigabyte to 16 terabytes of data and use it for anything you'd usually do with a hard drive. You can use multiple EBS volumes on the same EC2 instance. Amazon EBS is particularly suited for applications that require a database, file system, or access to raw block-level storage. Customers can create a file system on top of Amazon EBS volumes or use them in any other way they would normally use a block storage device, like a hard drive. Each Amazon EBS volume is automatically replicated within its availability zone to protect you from component failure, offering high availability and durability. Additionally, each volume can be backed up as a snapshot to Amazon S3 as an incremental snapshot for durable storage. Amazon EBS enables customers to provision a specific level of I/O performance by choosing a provisioned IOPS volume. This allows customers to predictably scale to thousands of IOPS per Amazon EC2 instance. EBS and provisioned IOPS volumes. Amazon EBS provides 3 volume types: standard, provisioned IOPS, and general purpose volumes. The volume types differ in performance, characteristics, and price, allowing you to tailor your storage performance and cost to the needs of your applications. Standard volumes. Standard volumes offer storage for applications with low or moderate I/O requirements. For example, they are suited for use as boot volumes or use with an EC2 instance performing light duties such as a bastion host. Standard volumes deliver approximately 100 IOPS on average, with the best effort ability to burst to hundreds of IOPS. In general, standard volumes are best suited for applications where I/O performance consistency is not critical. Provisioned IOPS volumes offer storage with consistent and low latency performance, and are designed for applications with I/O-intensive workloads, such as large databases. Backed by solid-state drives, SSDs, provisioned IOPS volumes support up to 30 IOPS per gigabyte, which enables you to provision 4,000 IOPS on a volume as small as 134 gigabytes. You can also strike multiple volumes together to achieve up to 48,000 IOPS when attached to larger instances. General-purpose volumes. General-purpose volumes offer consistent and low latency performance and are designed for applications with bursty I/O workloads, such as medium-sized databases. Backed by solid-state drives, SSDs, general-purpose volumes support up a steady state of 3 IOPS per gigabyte, with the ability to burst up to 300 or 10,000 IOPS during periods of high utilization. So far, we have discussed Amazon EBS, Elastic Block Store. Let's see how this compares to S3, Simple Storage Service. Recall from earlier that Amazon S3 is a durable, scalable object store similar to a collection of static files, featuring a web interface that can be used to store and retrieve data and files. Amazon S3 offers developers easy access to storage that is highly scalable, reliable, secure, fast, and inexpensive. You can think of S3 as a bucket of static files, where you upload and delete files, or you re-upload modified files. Some typical uses for S3 include serving static website content, for example, images, HTML, CSS, and JavaScript, backups, and storing data before loading into a data warehouse or Hadoop cluster for analysis. In comparison, S3 has higher latency than EBS. S3 does, however, let you serve the files to the web very efficiently, far better than EBS and your own web server. As an example, if you have a website with a lot of images and videos, the best way of leveraging EBS and S3 is to use EBS for the operating system and website files, and S3 for all the static images and videos. Images and videos never change. They are only added or deleted, and they need to load quickly on your website, so you don't want arbitrary limits on how many you can have. S3 is perfect for that. The third storage service we'll discuss is Amazon Glacier. Recall from earlier that Glacier is optimized for backup and archiving. It is best for data that isn't frequently accessed and for which retrieval times of several hours are suitable, and it is highly durable. Glacier provides several advantages over a traditional backup process. Traditional backup environments may involve copying data to tape, and then physically storing the data off-site. This process results in low durability, long recovery times, and potential high costs. In the AWS backup and archive environment, you simply back up to Glacier, and Amazon takes care of managing and securing the storage. Glacier gives you a highly durable archive with an average durability of 11 nines, retrieval times measured in a few hours, and costs that are as little as 1 cent per gigabyte per month. You can automate a lifecycle process to move objects from S3 to Glacier. Rules identify the affected objects, set a time frame, and specify actions to take. The lifecycle configuration enables a one-way transition from S3 to Glacier and sets the eviction schedule of the objects from Amazon Glacier for permanent deletion. Amazon also offers other storage services, including a network file system, content delivery network, and hybrid storage appliances. You can find out more at aws.amazon.com. AWS provides convenient tools to secure and administer your cloud resources. These tools are included in your AWS services at no additional charge. The two tools we'll look at in this section for securing and monitoring your cloud resources include AWS Identity and Access Management, known as IAM, and Amazon Cloudwatch. AWS IAM is a tool used to securely control user access to AWS services and resources. Amazon Cloudwatch monitors system metrics such as CPU and network utilization, along with custom metrics such as page load or query execution time, and allows you to monitor as much or as little metric data as you need. We will take a closer look at each of these. Security is very important for AWS customers, so security has always been a top focus and priority for AWS. IAM helps you create and manage users, user groups, and permissions to allow or deny access to AWS resources. It also allows you to grant access for users managed outside AWS. IAM can integrate with your existing corporate directory to manage federated users and their permissions. Some of the things IAM will manage for you include creating individual users, managing permissions with groups, configuring a strong password policy, enabling multi-factor authentication for privileged users, using IAM roles for EC2 instances, using IAM roles to share access, rotating security credentials regularly, and restricting privileged access further with conditions. Additionally, every AWS account has a master user, the equivalent of a root or administrator, and each master user has an AWS Management Console sign-in with an access key and secret key pair. When you create an AWS account, the root user initially has all permissions on all resources. It is up to you to create IAM users and set the appropriate permissions and restrictions for each user and group. Account management best practices suggest that you use IAM to create users and groups. Do not use the access key, secret key pair from the master account, but instead apply a physical multi-factor authentication to the Management Console sign-in. IAM can be used to grant your employees and applications federated access to the AWS Management Console and AWS Service APIs. You can do this using your existing corporate directory systems, such as Microsoft Active Directory, or you can use a third party, such as Login with Amazon, Facebook, and Google. In this example, your enterprise wants an application running on all employee laptops to perform daily backups to an employee-specific folder in Amazon S3. After establishing each user's identity as they sign into their corporate directory system, you can run a small client application that talks to a federation proxy requesting temporary security credentials for each user. These credentials are associated with a set of permissions. For example, write access to a particular Amazon S3 bucket and expire after a specified time period, for example, 12 hours. These credentials get passed back to the backup application on the employee's laptop, providing secure and direct access to the S3 bucket. Consider the following scenario and make a choice below. Your team needs to log into the AWS Management Console to create AWS resources, but don't want to have to create a new set of users in AWS Identity and Access Management, IAM. What should you do? Correct. You would use IAM Identified Federation with your existing Active Directory. By using one central identity management system, customers can spend less time administrating yet another environment while ensuring that everyone gets what they need. AWS IAM lets developers focus on the features and functionality of their application, while it does the heavy lifting on the security side of things. In addition to user management, AWS provides the physical security certification to fine-grained access, data locality controls, infrastructure building blocks, and compliance standards that customers and businesses require. We have covered AWS IAM. Recall from earlier that Amazon Cloudwatch monitors system metrics such as CPU and network utilization, along with custom metrics such as page load or query execution time. Scaling events, notifications, and other responses can be built around these operational metrics. Using Cloudwatch, you can easily monitor as much or as little metric data as you need. Cloudwatch lets you programmatically retrieve your monitoring data, view graphs, and set alarms to help you troubleshoot, spot trends, and take automated action based on the state of your cloud environment. Cloudwatch provides a reliable, scalable, and flexible monitoring solution that you can start using within minutes. You no longer need to set up, manage, or scale your own monitoring systems and infrastructure. Cloudwatch is accessible via the AWS Management Console, APIs, SDKs, or a command-line interface. We have covered AWS IAM. Recall from earlier that Amazon Cloudwatch monitors system metrics such as CPU and network utilization, along with custom metrics such as page load or query execution time. For analytics, Redshift makes it simple and cost-effective to efficiently analyze all your data. Amazon Redshift is a fast, fully manageable, petabyte-scale data warehouse service. It gives you the ability to analyze your data using your existing business intelligence tools. You can start small for just 25 cents per hour with no commitments or upfront costs, and scale to a petabyte or more for $1,000 per terabyte per year, less than a tenth of most other data warehousing solutions. Traditional data warehouses require significant time and resource to administer, especially for large data sets. In addition, the financial cost associated with building, maintaining, and growing self-managed on-premises data warehouses is very high. Amazon Redshift not only significantly lowers the cost of a data warehouse, but also makes it easy to analyze large amounts of data very quickly. Amazon Redshift manages the work needed to set up, operate, and scale a data warehouse, from provisioning the infrastructure capacity to automating ongoing administrative tasks such as backups and patching. Amazon Redshift automatically monitors your nodes and drives to help you recover from failures. Amazon Redshift uses a variety of innovations to achieve up to 10 times higher performance than traditional databases for data warehousing and analytics workloads. You can easily scale without any downtime. Just add more nodes, and Redshift automatically adds those nodes to your cluster and redistributes your data for maximum performance. There's no tuning needed to maintain performance or speed. Redshift handles all that for you. Amazon Redshift uses columnar storage and a massively parallel processing architecture to parallelize and distribute data and queries across multiple nodes to consistently deliver high performance at any volume of data. It also automatically and continuously monitors your cluster and backs up your data, so you can restore a copy of your data warehouse with just a few clicks. Encryption is built in. Just switch it on, and all your data and backups are automatically encrypted. As a SQL data warehouse, Redshift uses industry-standard Java database connectivity, Open Database connectivity, and PostgreSQL drivers. JDBC is a Java API that enables Java programs to execute SQL database query statements. This allows Java programs to interact with any SQL-compliant database. ODBC is a standard database access method used to access any data from any application, regardless of which database management system is handling the data. Many popular software vendors are certifying Amazon Redshift with their offerings to enable you to continue to use the tools you do today. Redshift offers the security you need. It provides encryption using SSL to secure data in transit and hardware-accelerated AES-256 encryption for data at rest. You can easily set up your encryption with just a couple of parameter settings. Redshift also provides network isolation that enables you to configure firewall rules to control network access to your data warehouse cluster. You can also use Redshift to integrate with CloudTrail, which allows you to audit all of your Redshift API calls for compliance. AWS also offers other analytic services, including a real-time service for streaming data, a managed Hadoop framework, and machine learning services. You can find out more at aws.amazon.com. AWS offers services to help with deployment automation, from application containers such as Elastic Beanstalk and the Amazon EC2 Container Service to application deployment services such as Code Deploy and OpsWorks. AWS offers you the tools you need to automate your environment. In this section, we will examine one of these services, CloudFormation, which automates the creation of AWS infrastructure and environments. AWS CloudFormation gives developers and systems administrators an easy way to create and manage a collection of related AWS resources, provisioning and updating them in an orderly and predictable fashion. You can use AWS CloudFormation sample templates or create your own templates to describe the AWS resources and any associated dependencies or runtime parameters required to run your application. You don't need to figure out the order for provisioning AWS services or the subtleties of making those dependencies work. CloudFormation takes care of this for you. After the AWS resources are deployed, you can modify and update them in a controlled and predictable way. In effect, applying version control to your AWS infrastructure the same way you do with your software. You can deploy and update a template and its associated collection of resources, called a stack, by using the AWS Management Console, AWS Command-Line Interface, or APIs. CloudFormation is available at no additional charge, and you pay only for the AWS resources needed to run your applications. This has been a long list of services. Many more are available that provide broad and comprehensive capabilities. In Module 3, we will learn how these work together to provide cloud compute solutions. Before we move on, let's first take a look at how you can access the AWS services. Part 2. How to access the AWS services. AWS provides several online tools that help you create and manage resources. These options include the AWS Management Console, the AWS Command-Line Interface, or CLI, software development kits, or SDKs, and query APIs. The AWS Management Console is a graphical user interface you access online at console.aws.amazon.com. The AWS Management Console is the fastest way to get started with AWS. There is nothing to install. Some services, however, have features that cannot be accessed from the console. For more information, see the service documentation. The AWS Command-Line Interface, or CLI, is for developers and those who are more comfortable typing in commands. A text-based tool you install on your computer, it connects over the internet to manage your AWS resources. several command line tools are available. The AWS CLI manages multiple AWS services through a single tool. Many services offer custom CLIs that manage only that service, and there are Windows PowerShell tools for AWS. For more information, see Command Line Tools on the Tools for Amazon Web Services page. SDKs provide cloud libraries and tools you add to your application so it can manage AWS resources. AWS offers SDKs in a variety of programming and scripting languages, as well as mobile SDKs for iOS and Android apps. The SDKs are the easiest way to write applications that manage AWS. They provide functions you can call to authenticate your application's connection to AWS. Query APIs are low-level APIs exposed online through service and region-specific endpoints. You call API actions by using HTTP requests. The APIs reflect the latest functionality of each service. If your application uses the API instead of an SDK, however, you must implement the functionality to generate the proper signatures to authenticate your requests. Choose from a variety of APIs tailored to your programming language or platform. AWS provides several electronic tools that help you create and manage resources. The DevOps and Cloud Services support provides one-on-one fast response support channel that is staffed 24 hours a day, 7 days a week with experienced and technical support engineers. The service helps customers of all sizes and technical abilities to successfully utilize the products and features provided by Amazon Web Services. All AWS support tiers offer customers of AWS infrastructure services an unlimited number of support cases with pay-by-the-month pricing and no long-term contracts. The 4 tiers provide developers and businesses with the flexibility to choose the support tiers that meet their specific needs. AWS support provides a highly personalized level of service for customers seeking technical help. Customers that do not select AWS support will continue to have access to basic support offered at no additional charge, which includes the Resource Center, product FAQs, discussion forums, and support for health checks. This concludes Module 2 on AWS Services. We have learned about core services in compute, database, networking, storage, administration and security, analytics, and deployment. And we have been introduced to methods of accessing AWS services, including management tools, SDKs and APIs, and support services. Before you move on to Module 3, please answer the following practice test questions. These questions will help you prepare for the accreditation test, but are not scored. Correct. Correct. Amazon ELB is used to balance network traffic between multiple EC2 instances. Amazon CloudFormation allows you to quickly provision replicas of your production environment to do development and testing. Correct. Amazon RDS can be used with Oracle, PostgreSQL, MySQL, or Microsoft SQL databases. You can alternatively use DynamoDB with NoSQL databases. Amazon Glacier is optimized for archiving and backup. It is best for data where longer retrieval times are suitable and where high durability is needed. Congratulations! You have completed Module 2, AWS Services. Next, continue on to Module 3, Cloud Architectures and Solutions.